Hi there everyone. So I'm just continuing with the topic of calculus, and in this video we are looking at the cubic function. So we're just going to go through some steps to draw a cubic function. The reason why the cubic function is put in the calculus topic and not with functions is because there's a lot of calculus things that we use in order to draw this function, as you will see. Okay, so we'll start with the regular things when we draw any function, the x-intercept and the y-intercept. So you guys are well familiar with this. To work out an x-intercept, you simply make y0. And once you make y0, you will then have to factorize the trinomial and solve x. Okay. For the y-intercept, you just make x0. But if you have a look at this equation, once we make x0, the answer is simply just 30, because all of these expressions just become 0. So that 30 at the end, that is simply then just your y-intercept. So I would say that sometimes you can actually just read off the y-intercept. Okay, then we get to the part where we actually need to use some calculus to find these things. Okay, so the turning point, to find the x coordinate at the turning point, you will have to take the first derivative and make it equal to 0, then solve that equation. And once you've done that, I guess you need to substitute that back. Well, there's an x value. After solving x, you'll have to sub that back into the original equation, or into the original function. I'll just put it f like that. Okay. Now for the inflection point, it's literally the exact same process, except we'll be taking the second derivative. So once you've worked out this first derivative, you need to derive that one more time and then make it equal to 0 and just substitute your x back into the original function to find your y coordinate. Okay, and last but not least, it's all about the shape. Okay, so the shape of our graph can either take this form or something similar to that, like this perhaps, or the opposite direction, like this, or like that. Okay, so I like calling this the up, down, up graph, and this one the down, up, down graph. Now, it's all dependent on the a value, which I call the a value. It's the value next to the x cubed. Okay, so if a is positive, it's going to look like that, and if that a is negative, it will look like these two. Well, one of the two, I guess. So let's keep all of this in mind, and we're going to have a look at this function and draw this function. So we want to start off by working out our x-intercepts and y-intercepts. But instead of factorizing or reading off the y-intercept, I want to go about it a different way using our calculator over here. So I want you all to take out your Casio calculators, press mode, and then I'm going to press 3 because I'm looking for that table mode. So table is number 3. I'll press number 3. Okay, so it gives me this fx equation, and I'm just going to type in this function that I see over here. So I press alpha, close bracket to get the x, and then to the power of 3 minus 4x squared minus 11x plus 30. Okay. And then they're offering me a gx. I'll just press equal to skip that. I'll start at -9. I want to make my domain as big as possible without breaking the calculator's memory, I guess. And then I'll end at 9. And I'll just keep my step 1. Okay. So each time just press equal to. Now, an x-intercept is where y is 0. So I'm going to look at my y column, and the moment I find a y that is 0, I'll know that is my x-intercept. So next to the y, next to the 0, sorry, that will be my x-intercept. So let's go down here. Okay, so we have my first, I have my first 0, and the x value is -3. Okay, So that's the first one. I guess I should write it down. Y is 0 where x is -3. Okay, let's keep going. Okay, again we get 0 where x is 2. So y is 0 where x is 2. Let's keep going. Here's another one. Y is 0 where x is 5. Okay, so these are all my x-intercepts. And I didn't do any work really to, get these answers. I simply just use my calculator. Now, if you want to know how to factorize a polynomial or a cubic function like this, just check out my other video that I'll be uploading shortly about factorizing these cubic functions. Okay, let's continue. So then we want to find our y-intercept. Now remember, a y-intercept is where x is 0. So I'm going to go up my table to look where x is 0. Okay, and there I get 0 and 30. But remember, we knew this already because we could just read off that value over there. Okay, so these are all my x-intercepts, and my y-intercept will then be, oops, what am I doing? My y-intercept is 0 and 30. The 0 is first. Okay, now I need to find my turning points. Okay, so to find the turning points, we first need to take the derivative of the function and then equate that to 0. Now, the derivative of this function will be 3x squared minus 8x minus 11. Okay, then I will factorize this to solve x. Okay, we'll sub in, we'll get the factors of 3x squared, which is 3x and x, and then we'll get the factors of 11 combined with this to give us that -8. So the 11 has to go over here and the 1 over there. This bracket gets a negative, this one gets a positive. Therefore, x is equal to 11 over 3, or x is equal to -1. Now, I still have my calculator over here, and I still have the table open on my calculator. So I'm just going to check where x is -1, what is the y value? And I get this answer 36. So I already know that where x is -1, my y value is 36. Cool. So now I just need to substitute x with 11 over 3. Okay, so I'm simply just going to use my calculator again. And I guess I'm going to start at, let's make it 11 over 3. Okay, that bracket thingy means divided by, means division, so 11 over 3 equal to, well, we'll end also at 11 over 3 because I'm just looking for the one value. So there we go, that's the answer. 3,66666666667. Okay, I guess either I can write it as a decimal. Oh, sorry, that's the x value. Sorry, that's just the 11 over 3 as a decimal. If we have a look at the y coordinate, that is the -14.81. Okay. -14.81. Now, the fraction version of this is actually 400 over 27, but this is basically the answer written as a decimal. This is the answer written as a decimal. Okay, cool. And I guess it's more helpful because we'll know how to plot points better if it was a decimal rather than it being a fraction. Alright, so that's the turning point. So now I just need to work out my inflection point and then I'll go ahead and draw my graph. Okay, so I now need to take my second derivative and make it equal to 0. Okay, so I'm going to derive this once more. 3 times 2 gives us a 6x, and then we just left with a -8, the 11 falls away. Okay. Now I'm going to solve x by taking the 8 across, and then I'm going to divide by 6. So 8 divided by 6, if I were to simplify that, I'd get 4 over 3. Okay, so again, like I did for the 11 over 3, I'm also going to substitute this into my calculator. Now I did that already, so I think I remember the answer for this one. I think this is simply 208 over 27, if I remember it correctly. Otherwise, you can just write it in its decimal form, which is 10.59. Or you can just say 10.6, I guess. But okay, so we've done all the calculations. This is the inflection point. We've worked out the turning point. So now we just need to figure out our shape and then plot it. I guess plot the points, figure out the shape, and draw the graph. Now, before even drawing your graph, I first want you to draw a nice and accurate scale. Doesn't have to be super accurate, but at least roughly accurate. The spacing between each numbers from the origin should be equal in all directions. Okay, and the scale that you use for your x values doesn't have to be the same for the y values, but still they should have equal spacing. So for example, here I have from 0, 1, 2, 3, 4, 5, but then for my y's I have 0, 10, 20, 30. Okay, but the spacing between 0 and 10 is the same as 10 to 20, and the spacing that I have for 1 to 2 is the same for 2 to 3 on my x-axis. Okay, so that's the thing that you need to look out for. Otherwise, we're just going to go ahead and plot all our points and then draw a nice curve. So I'll start with my x-intercepts. It was -3, it was 2, and then it was 5. My y-intercepts was 30. Okay. And then my turning points was -1 and 36, so it should be slightly higher than 30. And then my other turning point was 3, 6, 6, 6, 6, 6, 6, 7, and -14.8, so somewhere in between 10 and 20, like over there. Okay, so now just go ahead and draw a nice curve. Let's try and do this free-handedly. Okay, I didn't do too badly. Okay, so that's a nice cubic function curve, and there you go. I guess in my next video I'm just going to speak about this curve a bit, maybe take you through why we actually make the derivative equal to 0 when we work out the turning point, and maybe just speak on the inflection point a bit, like what the importance of that is, and maybe some extra details also. I'm not sure, but yeah, this is as far as it goes in with regards to drawing the graph. So yeah, hope you enjoyed this. Yeah, see you in the next video.